I'm Bram Geers. I'm an ecologist involved in this project, and I will give an overview of our holistic approach to the sargassum problem. So sargassum is a brown seaweed, and what's special about sargassum is that its full life cycle is spent afloat, so it floats in the ocean. And this is a picture of the Sargassum Sea, which is actually named after the seaweed. And it's characterized by forming an ocean gyre. So the ocean currents are cycling around, and that's keeping the floating material inside, which also keeps the sargassum inside. What trees are to a forest, for instance, like the Amazon forest, that's sargassum to the Sargassum Sea. It's really the foundation of all of the big ecosystem. It's a very biodiverse area with lots of species, lots of fishes, important for humans as well. And another thing, it's very interesting in terms of climate, because the Sargassum Sea is basically a big carbon pump. It draws down more CO2 than the Amazon rainforest, and of all global carbon dioxide being sequestered by nature on the planet, 7% of that is sequestered in the Sargassum Sea, which is quite a lot. So in this case, sargassum and the Sargassum Sea is a very positive thing for our world, but things have been changing, as you can see in the next slides. This are some satellite images of the last 2 decades, and what you see, these colorful dots in the ocean, are actually sargassum growing. So this is up until 2011. 2011, this is the normal growth. We know that for as long as human history recalls, it's like this. And after 2011, things start to change. You see these big plumes of sargassum going from the Atlantic Ocean along 8,000 kilometers into the Caribbean and the Mexican Gulf. And these big plumes of sargassum wash ashore on beaches, and there they form thick mats like meter high, and the coastal areas are really inundated with all this sargassum, and it's causing a lot of problems. It's scaring away tourists, and for this area it's very vital for their economies, tourists. But it's also causing health problems. So the rotting, decaying mass is staying at the beaches. It will rot, it will stink, and the stink will cause breathing problems. And next to that, we're only finding it out that it's also causing massive ecological problems in these coastal areas. And unfortunately, Federica Ragazzola couldn't be here, who would like to tell something about the ecological effects of sargassum inundations. I will tell a bit about it. The sargassum mats that forms in the coastal areas will suffocate lots of life that's there. The degrading and the compounds that leach out of it are toxic. It will suffocate fish and other marine species, and some of the most pristine coral reefs, mangroves, and seagrass fields, which are very important for the whole marine ecosystem, are suffocated by this biomass. And 2018 was a record year, not in a good sense. It was 20 megatons of biomass, and it really is a lot. If you would put that in a cube, it would be 13 kilometers across, just to get a picture. And the thing is, we don't know exactly what's causing it, but there are a couple of ideas. One thing could be climate change. But maybe that's not the case, because sargassum actually prefers colder water. But the atmospheric concentration of carbon dioxide is really high, and that in itself could promote growth of plants in itself. So that could be a driving factor. The other thing is that this is a map of the river basins of this area, and you can see here is the Amazon River, the Mississippi, and the Congo River are one of the biggest river basins, and these river basins are characterized, unfortunately, by lots of um the degradation of forests, soil erosion, and an increase in fertilizer use. And all these nutrients that um, are washed into these rivers and are pumped into the Atlantic Ocean. And of course, fertilizer can grow plants on land, but it will also fertilize plants in the sea. So the likely cause of these sargassum blooms is over-fertilization, and likely also the increase in carbon dioxide. And this is very important to realize, because if you would look at sargassum as a simple problem, you think, oh, a simple tech fix, we harvest everything, um, which I think is impossible, but if you harvest everything um, and then maybe make a product out of it and think you're done, it's not the case, because you've got these fertilizers, all these nutrients in the water, and all the conditions to promote plant growth. It's just waiting for another plant or algae to take over. So it isn't solving anything, and that's why we would like to have a more holistic approach to this problem. Uh, so in this slide, you can see an overview of our solutions. What we think sargassum also might have its positive effects in the open ocean. It's promoting biodiversity. In other areas, it could be having positive effects as well, and it's also sequestering these nutrients and carbon dioxide. But it really gets problematic once it gets ashore. So we also don't want to clean up the beaches. We want to be before that. So we want to have a system near shore that prevents sargassum from beaching, having its negative effects. And we might do that with booms. Normally these floating booms, these sheets that will can prevent oil spills, but we can also use them for sargassum to stay near shore, and then we can concentrate it to harvest. In that process of harvesting, we would like to separate all the living animals and other life to harvest in an ecologically sound way, so we don't kill turtles or other marine life, but harvesting it in a eco-friendly way. And then it's a lot of biomass. We might be using it for products. So one of the things we're investigating is, for instance, energy. We can make biogas from it for using to replace fossil fuels. We can make fiber material or bricks, fertilizers or compost. And all these products will either prevent emissions of carbon dioxide or sequester it in these materials itself. But we wouldn't be called climate cleanup if we didn't have a more ambitious approach to this. So in the natural ecosystem of the Sargasso Sea, sargassum at the end of its life will sink down. Lots of other species will grow on it. It will get heavier, and then it will sink to the ocean floor. There, some animals will feed on it, but basically it will form a sedimentation layer, and this sedimentation layer will stay there for thousands of years. So that's different from these products, which will only last a couple of years. Is there will stay thousands of years. So that's why we want to investigate whether we can have a ecologically sound approach to sinking off huge quantities of sargassum biomass to the ocean floor. But therefore, we really need to understand the full ecology of the ocean, the full ecology of sargassum, and mitigate problems instead of using quick technical fixes and creating new problems. Um, and therefore, we sent two guys to St. Martin, and I want to give the word to them.
Thank you, Bram. This gives a very good highlight of what sort of led us up to this moment and being here. Um, we we also use, in terms of our outlook, the satellite data, and this is one of the tools which is provided by CLS, a company taking in all the satellite data and combining it with the ocean currents and trajectories. This gives a view of a run which is based on 31st of August, and then see the projections, and you can see actually that the Sargassum trajectory, where it was sighted all the way here and getting close to the area of St. Martin, in providing the Sargassum, which we knew that it was coming. Um, Although the satellite data is not always as accurate and in detail, uh, not always picked up by the satellites. And so we really had to sail quite a bit around to find the sargassum in the sea. But this gives a picture of how much technology is already being deployed in finding the sargassum, doing forecast on it, and being able to understand where it will beach. Um, and so wanted to show you this, next to, of course, the local sightings from the people who have been helping us, and of course telling us that there is a lot of sargassum at the island at the moment. One of the things is important to understand, and this is a picture from one of our trips, where you can see a strand of sargassum, and in the right bottom you see a phenomena which is very important to understand, because the sargassum is floating in a kind of Langmuir lines, and they cause the sargassum to actually form long strands which are 100 meters, hundreds of meters long, floating in the water, a bit diagonal on the wind waves of the ocean. And because the sargassum has a lot of drag in the water, it's actually floating quite fast through the water. So if you want to catch it, it's really kind of a challenge. But you see those strands in bigger and in smaller quantities floating around the surface of the seawater, and happily floating along. And so you see a patch here, you see a patch over here to the left, and it all depends, of course, on the currents and how much sargassum is available. But so you get an idea of how this looks like when you are here on St. Martin. On the left, you see those big ferries, which are currently basically stranded because of COVID over here in Great Bay on the island. So that really gives you an idea. We crafted from a lot of materials kindly provided by the Nature Foundation at St. Martin, a net which we tied to the boat, and we will share you our Polar Steps link later on, so you can get a lot more detail and a lot more information. But we didn't want to inundate you with lots of pictures and lots of the same stuff, but you can go in there. We'll invite you to this. So this will give you a complete overview of all the steps we are taking during this trip. We used the boat from Nature Foundation, and we sailed to the area just off Point Blanche, where, let's say, the south side and the east side of the island are intersecting, and there we found the sargassum. It's a makeshift net just to be able to harvest it out of the water, from some agricultural net with some buoys we found, some lines, and so the water flows into the net together with the sargassum. The net holds the sargassum, and the next thing is we take it out. Let me see if I can show you a quick video of how that would show. If I can share this one. Can you see this? You can see this floating into the net. So you can see the makeshift net. You can see how it actually functions. You can see the strands coming in together with some seagrass. And we are continuously directing the boat to allow the sargassum to float into the net. Hopefully this gives you a bit of an idea of how that works. Going back to the presentation. And we have much more footage on this. Again, lots of stuff to share, and we have done that through the Polar Steps application. So I'll extend that invite to you later on during this, at the end of this talk. So we made some pictures of how it looks like from below. This is a picture made by Melanie from Nature Foundation with her underwater camera. It really looks like a forest. It stays like in the upper meter of the water. It's really quite beautiful if it's fresh and if you're swimming around it. This is sideways. You can also, what you will see is that it's quite yellow gold in its color, and the moment it starts beaching and it starts washing ashore, it decays quite rapidly to a very dark brown, red brown color with also a lot of, you can see the carbon inside of it. We crafted a little bit of wheat block area, which is the black sail which is on the floor, which makes a good sort of heat trap also from the sun from above. And what we have been able to do with this is that the fresh sargassum, we put it out in the morning, so we know it will not rain, and we can keep an eye on that. But if we do this in the sun and the weather conditions with the wind blowing 4 or 5 before, it dries within 1 day. So that is quite an effective way of drying the sargassum and helping us to collect it rather efficiently, and you know, drying it to the 150 kilograms as planned. We were very lucky to be able to rent an accommodation with an open piece of land right next to the sea at Simpson Bay. So we're very lucky to really effectively and efficiently work on this beach, and the neighbors are coming to visit us every now and then. What are you crazy guys doing, and what is this? So it's really neat to be able to tell them what we're doing and explaining and getting some local insights as well. So that's what we are doing. Here I give it a little bit to Fons, because then he can share his biology and biotech insights in terms of how the sargassum actually grows and develops, and you can see how this all works. Go ahead, Fons.
Yes, so my name is Fons Jansen. I'm 24 years old and I study at the Wageningen University. And I'm on this project, the Sargassum Cleanup project, for my graduation internship. So since March, I've been active in doing the literature study, and I'm very glad that despite COVID, I'm able to go on this trip and really have hands-on experience how it is catched, and also later on how it is processed, so that I have got a good view on the value chain, how we could valorize the sargassum as good as possible. So here you see one fresh piece that we just picked up from our first sale. So you see that this sargassum is growing already quite old, because you see on the yellow side on the right, you see very yellow, and in the middle is quite brown, and on the end you see no bladder anymore. So you see that it is already quite old, but that it is growing in the sea. So that you see that these pieces keep growing, and when they become probably too big, they break apart. So that's why when we were harvesting them, we see a lot of different size and pieces because of the probably of the breakdown and the growth of the sargassum. But if it gets older, we saw more and more encrustation. And here I show you a few examples. So here you see a lot of tiny shells on it. Next to it, you see a scale, so it is 1 millimeter or even smaller. And you see also a fine white lines, which is also a type of encrustation. Here you see another type, so that's a kind of an epiphyte or encrustation that a plant grows on the sargassum. So it has veins spread all over the bladders and the stem, and it makes its own spikes. And these kind of encrustations are called bryozoa. And here you see the last type, which looks like a panty, in which it covers all over the stem and sometimes also over the air vesicles. So what this effect has is that it really covers the complete sargassum. So right below you see a picture that is almost fully encrusted. And on the left you see that also this encrustation also happens at the air vesicles. And when we were squeezing those air vesicles of the fresh ones, they really popped. So they really saw that they can withstand the pressure and that there was a hole with air in it. But when we were pressing these older brown air vesicles, they actually didn't pop. They became more spongy and they did not contain any more the air. So the older the sargassum gets and the more encrusted, the heavier it becomes and the less floating capacity it has. And then it probably will sink on the bottom, as Bram explained, in the Sargasso Sea, but probably also in the Atlantic. We also catch some interesting species next to it. Here you see a small overview. We caught some tiny shrimps on the left side, some crabs, and these crabs actually ate our shrimps when we were catching them for the first time. So in the first catch, we didn't find a lot of shrimps eventually in our tube because the crabs ate them. There were some small slimy organisms, some seagrass, and we also catch even a juvenile fish. We still have to do some quantification about how many of these species there are, but the main species that we found are the small shrimps and the crab. Here you see a good visualization of how it's beaching. So this is at Guana Bay, and you see that the fresh sargassum is coming up, and you see a gradient of color. So it becomes dark brown and then really red to black. And when we look even at older sargassum pieces, it really becomes carbon. It becomes completely black, sunburned, in which all the fresh materials are just dried up and completely cooked on the hot sand. But actually also the local government was cleaning up one of the beaches. So it was Point Blanche Bay. And they actually also made a heap, which actually looks like a compost heap. So we have taken samples of it and we will analyze it. And this is just probably 3 weeks old, 1 month ago, that the government came by and cleaned the beach and made this heap. And we see that the sargassum is mixing with the sand and could possibly give fertile soil. But that's what we need to find out later this year. When we were observing the fauna and flora on the beach, we saw some of these plants all covered about, but we do not know if these plants are growing on the sargassum, and actually we did not see a lot of plants on the sargassum. So we are still not sure if it promotes plant life on the beaches or not. But what we see is that the beach fleas are really feasting on the sargassum, because when it's beaching, it mixes up with like layer upon layer with sand. It gets mixed, and when we were opening up one of these banks that you see on this picture, a lot of beach fleas were there. So I just took one hand of sample, and I catched at least 200 of these beach fleas, from older types to very young ones. And we saw also quite some birds that you see below, also just walking around and eating all these beach fleas. Another interesting finding that we also saw from the literature in practice was the leachate. So when we were walking at Guana Bay, you see that the Sargassum is flushed multiple times, and every time when it was flushed, it left this brownish greenish color on the beaches. We still need to take samples and to analyze it, but probably it will be quite sour because some of the sulfur gets released from the Sargassum, which makes also the sea locally a lower pH. Lastly, indeed, we also interviewed some of the stakeholders. We had some neighbors that indeed complained about their asthma and about their eyes being very sour and dry. And they were just really living close by, and they did not have any information about the sargassum, what it means, and the potential health risks. We also see that hotels are like having quite clean beaches, but that like they probably are cleaning relevant. There are no fishermen on this island, but on Seba there are. So hopefully we can give some calls and ask fishermen about what they're experiencing. At least one person that is also managing the yacht harbor actually had a lot of experience in it when he was fishing. So hopefully we have a talk with him later this week.
Right.
And yeah, a lot of local people are not aware about the type of seaweed. They're mentioning something like sea moss and that they could actually eat the sargassum, or that when we were drying it, they were thinking that we could make food out of it. But we're not very sure about it because it contains a lot of salt and very few proteins, and also some heavy metals, which actually pose risks to health. So probably drinking the proteins out of it would not be a directly good idea. But it was very, like, a lot of people are very open to share their insight, like their thoughts and how they are dealing with it. We are looking very much for it.
To be adding to this picture, it gives a view on Guana Bay, but this beach has already been cleaned, and so what you see is actually very, very mild in terms of the amount of sargassum beaching at this moment. When really the mets are hitting the beaches and the bays, you have to think completely covered and up to meters high of sargassum, which you see here where the dogs are playing, but then let's say 10 times higher in terms of volume. So we're still in sort of the mild season from a sargassum perspective. It was much worse. So just to give you an idea of how bad it can get. And when we talk to the locals, they are complaining about their health, about breathing problems, having to take asthma medicine, because it's really causing damage there. Also, the fumes coming out of the decaying sargassum, they are sulfuric, so they cause a lot of damage to the electronics, air conditioned systems, all the electronics nearby, they get impacted. So if you think about, let's say, the impact of sargassum, not only on the fact that the tourism won't come, there is also, let's say, the other effects which are much more prolonged, and therefore, it's really important that it is cleaned actually quite fast when it beaches. And the best thing, of course, confirming our notion, is that you actually need to make sure it doesn't beach, because then you can take it out and have a mitigation of the problem instead of solving it after the fact. So that, I think, is a very important understanding for everybody to know how the dynamics work. In that sense, we have an outlook for the work we want to do in the coming days. We believe with some 2.5 big bags now harvested with dry material, where we're sort of almost done with 150 kilograms. Some more work on the ecological quantification of how much other fauna is coming along with the sargassum, depending of course on the where and the how we harvest it. We will also do some environmental experiments with some analysis on the acidity and the dissolved oxygen in the water, especially where the sargassum is floating in bays and it stays there. And of course, the currents and the waves, they keep on washing the sargassum, but you can actually see already the bubbles from the decaying in the water, and so it takes out a lot of oxygen, which causes fish to have too little oxygen in the water. The leachate leaking out of the sargassum, it will bleach the coral, it will smother the seagrass, it will smother the mangroves, and because they are also, especially seagrass and mangrove forest, very, very potent carbon sinks, far more potent than forest and trees. Those are vital ecosystems to save our planet and to manage a livable planet. So that's sort of in a nutshell where we are right now.